Hi everyone, this is the first video for section 6.4. So this one, we're talking about ratios and proportions, which is essentially an application of fractions. It is what people use fractions for in real life. They use it to talk about ratios and proportions and things of that sort. So this is where it comes up in real world applications. So what is a ratio? So a ratio is a comparison between a number A to a non-zero number B, and it's just the quotient when A is divided by B. And it's written in different ways. So it's written as a fraction, and when we write it as a fraction, it's really easy to see. It makes more sense why it's a quotient. So because fractions imply division, and so a ratio is a quotient, so we write it as a fraction. I think the most common way that we write ratios, so we have a fraction with this colon and then in words. So I think the colon is the most common way that I see ratios written, is with this colon. So that's the most common way. So fractions kind of help us remember that it's a quotient, but the colon is the most common way, and then you can also say what a ratio is in words. It's 3/5. 3 to 5. And so whenever you say a ratio, you say it in words like that. So if we were to just say this ratio out loud, it is 3 to 5. And so that's how you would say it. So ratios can represent a lot of different relationships. So it can represent part to part, part to whole to part, and whole to whole. So pretty much anywhere you can have part and anywhere you can have whole in this. So the book only talks about part to part, part to whole, and whole to part. So we're going to add talking about whole to whole. Okay. So remember that fractions are typically regarded as part to whole. So typically people write ratios as a fraction if it's part to whole is whenever we typically write a ratio in that fraction form, because fractions do represent part to whole relationships. Okay, so we are going to look at some ratios, and we are going to label them as part to part, part to whole, or whole to part. Okay, so Grandma's Wedding Punch is 1 part grape juice to 1 part ginger ale. So this is one way where ratios come up, is whenever you have recipes. If you have any recipe, right? I mean, this one doesn't say what measurement we're using. It doesn't say 8 ounces grape juice, 8 ounces ginger ale. It doesn't say 1 liter grape juice, 1 liter ginger ale. It doesn't tell you what the measurement is. It just tells us what portion of the punch is going to be made up of grape juice and what portion of the punch is made up of ginger ale. So this can be represented as the ratio 1 to 1, meaning that there's equal parts grape juice and ginger ale, meaning that half of the punch is grape juice and half of it's ginger ale, and it mixed equally. So this is going to be an example of a part to part relationship, because part of the punch is grape juice and part of the juice is ginger ale, and we compare those parts in this ratio. Okay, and this is one way that you can change recipes. When people, even if you just have a recipe that makes 4 servings, but you are making it for a party, so you want it to have more than 4 servings, you can use ratios to say, well, it says I want to use, so if you want to double a recipe and it uses 1 cup of something and 1 cup of something else, well, you just double it and just make sure that you have the same fraction of parts going into the recipe. Okay. B says, at a particular school, for every 4 students, there are 3 women. So most of these, so for every 3 students, there are 3 women. So this can be represented by this ratio, 4 students to 3 women. So most of these, how it's written is going, if it says 4 and then 3, it's typically going to be represented by the ratio 4 to 3. And so this one represents a whole to part ratio. A whole to part ratio, saying that, well, if we have 4 students, that's all of the students we have, then 3 of them will be women. And you can see that if you were trying to convert this into a fraction, then we would again put part over whole and say that this represents that we have 3/4 of the students are women, because we think of fractions as part to whole. But ratios can be represented anyway. It just depends. That's why in the way I wrote this at first, I included our units where we have 4 students to every 3 women. If you're doing things in a context like this, it's nice to have the units in that ratio. Okay, the next one talks about odds. So the odds that the horse Terrible Tom will win his next race is 3 to 14. So odds come up a lot in ratios. That is probably the main application of ratios, is talking about different odds of things. So you may have heard odds if you've ever taken a class where you talk about probability or statistics, because it's very related. But the way that we typically think about odds, so it tells us it's 3 to 14. So it gives us the ratio in words, and we just put it in a ratio. But this, what odds really means is that there's 3 ways in which he can win. So there's 3 outcomes in which Terrible Tom can win, and there's 14 different ways that Terrible Tom can lose. So there's 14 outcomes where Terrible Tom will lose. So this is typically how we talk about odds, is the odds that someone will win. The first number is always the number of ways they can win, and the second number is the number of ways they can lose, and vice versa. If you're talking about the odds that someone will lose, that means the losing outcomes come first. So since we have 3 winning outcomes and 14 losing outcomes, this represents a part to part, because we're looking at part of the outcomes to another part of the outcomes. We're looking at losing to winning outcomes, so the part of all the outcomes to another part. Okay, the next one says that in a figure of 8 squares, 5 are colored red. So out of 8, this can tell us that we can write this as a fraction. So out of 8, 5 of them are colored red. So this means that 5/8 of the squares are red. And so this one can represent a part 2. So part to whole, and we wrote it as a fraction because of that. So part of the squares are red out of all 8 of them. And lastly, in our base 10 number system, each increase in place increases the value by a factor of 10. So you also hear ratios a lot in this context. It increased 10 to 1 is how people say this. So if it increases by a factor of 10, that means it increases 10 to 1. And so this is an example of a whole-to-whole comparison. And so it's a whole-to-whole comparison because it's representing 2 different numbers that are completely themselves, right? So if we're in base 10, we're not dealing with any fractional parts of any number, right? We're only dealing with whole numbers. And so we're comparing 2 different whole numbers, and depending on where their place value is. And so that means we're comparing one whole number to another whole number. So this can be regarded as a whole-to-whole comparison. Okay, so that's the basic of ratios. It's covered on the first 2 pages of the book. Yeah, it's covered on 231 and 232 in the book. It's pretty much this exact same thing with some other types of examples. So that's all for our basics of ratios, and that's all for this video.